Hey, Angel.
Hi, Tyler.
You're 6 minutes early, dude. So Lisa, just start setting up your documents. About to start in a moment. Okay, so this is 10 more minutes to just make sure everybody gets in class. They'll be marked late if they're not here. So far as Lisa and Angel that made it to class. Hello, Ms. Camacho. Welcome to class. You might want to start setting up your screens so we can get started on today's assignment. As a reminder, all students need to have their cameras on and they have to stay on the entire class period to make sure it doesn't affect your attendance. If your camera's off, I'll try to get you to turn it on within a 10-minute time frame. And if you do not, then I'm going to have to remove you from the classroom and mark you absent. And you have to try it again tomorrow. So please, please, please. I see everybody's got their cameras on so far. Leave your cameras on the entire time. In 7 minutes, we're going to start our norms and begin today's assignment. Okay, so let me run through attendance real quick. Present, sorry, Alan is absent. Lisa Brown is present. Camacho is present. Mario Carvajal absent. Christopher Clark absent. Courtney Dixon is present. Garcia absent. Romel Lee absent. Rashad Lockhart absent. Angelique Llewellyn. Let's see who's coming in the room. It just rang. So, okay, Angelique Llewellyn is here. All right. Mark her here. Aaliyah Mims absent. Angel present. Dick Pen absent. Wallace absent. Worthy absent. So we have 4 more minutes before we start. Everybody might want to get their screens resized and log into EDSB as well as your Gmail account. We're going to get started on today's assignment after the norms are recited.
Mr. Tyler, can I go to the bathroom?
Yeah, yes, Lisa, just come back.
Okay.
Mr. Dixon is on, but I can't see if it's you in the camera. You turn on the light? Oh, okay. Yeah, you got to stay in the camera, sir. It might help you to sit up and work, but you got to stay in the camera. You guys can't point it to the sky. There's no way to know if it's you or not. Okay, so we're gonna go through our norms real quick. I think this is everybody that's gonna be here. Let me get the norms up. There we go. Expand that. All right. So let's go down a list and let's all participate so we can get points. I think Lisa will be back, so I'm gonna come back to her. See everybody. Okay. So Angel, can you read number one, sir? You turn your microphone on.
Number one, no one has the right to hurt another person.
Thank you. Angelique, can you read number two?
Education in the classroom is secret.
Thank you. Number three, Mr. Dixon.
We'll never behave in a way that will discredit ourselves, our school, our family.
Thank you, sir. Let's see here. Jacqueline, can you read number four?
At Excel Academy, Southwest student is always a lady or gentleman.
Thank you. Let's see here. Number five. Lisa's not back yet. Angel, can you read number five?
We take pride
Take
in
pride in
serving.
Academy Southwest.
Thank you for Courtney for stepping up. Let's move on. Courtney, can you go ahead and take care of number one then?
Respect the opinions of others.
Thank you. Angelique, number two.
Respect
Llewellyn.
the culture of the classroom.
Okay, thank you, everyone. I heard you, Angelique. Thanks. Number three, Jacqueline.
We are attentive and participate.
Thank you. Lisa, are you back? Okay. Let's see here. Angel, do we read number three? Number three.
Yeah.
Okay. How about number four, Angel?
All right. We have high expectations of ourselves, our peers, and our teachers.
Okay, last one. Courtney, can you read number five?
We are here to focus on preparing ourselves for post-secondary endeavors.
Awesome, awesome, awesome. Okay. So everybody, let's direct our attention to so what is the title of today's assignment? Someone can put it in the chat. All right. Nobody wants the points. Going once, going twice. All right. Well, if you were not aware of what the title is, it's right in the assignment for Edsby today. And that is what's the equation of motion, right? And in question mark, and then the term for today is position. So if you have the definition of what's in brackets somewhere in your document, you'll get part of the 25 points for the word of the day and term of the day. And later on, I'm going to give you as exit slip opportunity to put in the definition in chat what the today's word of the day means. Okay, so we're going to center this. You should have typed up as much as I have and have your document ready. Okay, so that's the title in the middle, your header. Don't forget to name your document so you can find it later on. Change the zoom on this. Okay, there we go. So you guys see it better. Okay, so let's start off with some. I'm gonna call on students to read certain parts of today's agenda so we can get right into the problem. So let's see here. There. Let's see here. Mr. Angel, can you read what's in the chat for me? Angel, you there? All right. Let me go to Jacqueline. Can you read what's in the chat?
Oh, yeah, hold on. Hello and good day to all future physicists. Always remember that all as synchronous problems need to be completed and ready to be presented tomorrow in class. Synchronous problems have to be completed as homework and will be checked tomorrow in class as well.
All right. Thanks, Miss Camacho. Okay, Lisa's back. Cool. So, Lisa, I need you to read something for me. Because you had missed the norms a little bit. So I'm going to have you read a little bit out loud for the class. Starting with this. You see it in chat?
Yeah.
Okay.
Please remember to get maximal credit. All calculation steps for the final answers to the problems used to be uploaded to ESB. These are the same format that we have been using since the start of the quarter. This format is shown in the video typed Google Doc converted to PDF. Stay safe out there in Zen.
Thank you, Lisa. So let me see here. There's our problem for today. You know, take that, and Lisa, can you read that as well to start us off?
1S. A bowling ball moves with constant velocity from an initial position of 1.6 meters to a final position of 7.8 meters in 3.1 seconds. A. What is the position time equation for the bowling ball? B. At what time is the ball at the position of 8.6 meters?
Thank you, Lisa. Okay, so let's continue on. You want to take this problem and copy it over to your Google Doc. So come over here, expand, and we're gonna paste this into our document, right? Make sure you right align it, or I'm sorry, left align it. So it's not in the center like mine's. And you should have this much on your screen. Okay. So document title, header, the title itself, and the body of the document, and then the problem itself. That's where we're starting at. Okay. Take a moment to type that up. Okay, so now you're going to need like a few things to calculate how this problem works out for you. So I need you to type what I type, but make sure you center the typing because these are your notes for class, at least for tackling this problem. So who knows what the word of the day term of the class means? It's position. So let me give someone an opportunity to at least type in the definition of position. And that's what I put in the brackets if you're not sure how to spell it. It's position. So take a moment if you know what it is. But we're going to go into some position equations or position time equation of motion. I think yesterday we worked on a graph for position. Now we're going to actually recreate the mathematical representation of those graphs. They look like the equations of lines. So give me a second. I'm going to bring up a simulation for you guys.
You said the meaning for position?
The meaning of position.
I think I pasted it.
Yes. Yes. You could have just, that's good. But actually, position is just in meters. And you said a long definition of at least, but you got the points. So make sure you put that in your document. Position dash, as in the definition of it, is your statement, and you'll get credit for that. But all position really is just it's measured in meters in terms of physics. Okay, so let me grab this. No, that's Java based. I need something that's easy for you guys to open because I'm worried now you guys might have Java installed on your computers. Okay, so let me start this and make sure it works. It should work. Yeah, and we're going to go to this today because we're going to talk about motion a little bit. Now, when you get to this, let me first put the link in the chat because you guys got to take snapshots, 2 snapshots of your simulation, and then we're going to work on the problem. So let me come to the chat and put this here. Please open the link up now. I need you to open it up so you can follow along what I'm doing, because we're going to be taking snapshots of this simulation over to our Google Doc like we did yesterday. But yesterday we did more of a graph snapshot. Today we're going to go through a simulation and give you an idea of how motion works in real time. So is everybody on this page where it says forces in motion basics? You should be able to just click on the link and get started. Okay,
Yeah, I'm on the page.
thanks, Lisa. I was going to say, I'm assuming that's a yes. So the one you want to click on today is motion. Once you click on motion, it should give you this screen here. We're going to focus on speed mainly. The values, make sure you click on the things I'm clicking on.
Excuse me.
Go ahead, sir.
Can you just give me like a good 2 minutes?
Well, I'll give you 2 minutes.
1 minute. Because this computer acting real slow.
All right, so I'm gonna give everybody 1 minute to catch up to where I'm at. You just need to get to this screen. You can start manipulating things on this screen, like while he's getting it together. You have this a wooden character, and you can apply a certain amount of newtons. Now, you notice if you press 1 Newton, he's slowly pushing. And I talked to you guys about energy in terms of acceleration. A Newton is basically F equals ma. And we're going to talk about that more next week with Newton's laws. But if I apply more newtons, this is exerted force, it starts to go a little faster. And if you pay attention with these values selected, it says applied force is 3 newtons. And how fast are they going? Remember I talked to you about speed or velocity, it's 1.5 meters per second. So what you're going to be responsible for is what happens to this wooden character who's actually carrying all of this. This is where we click on masses. All right, that was the 1 minute, so let me turn that off. And what I want you to do is to apply just enough Newtonian force to make them go at least, let's see, I want to go at least 3 meters per second. All right, so I'm getting there. Notice I got to keep changing my force to match the mass, which I have is 80 and 100 kilograms. All right, and I wanted to get, like I said, to at least 3, so I'm a little over. I'm gonna bring it down 1 Newton. And let's see what speed it gets at. So it should slow down, and it'll be, yeah, it's going down, and it'll be a speed of at least close to 3, but not over 4. And it's only doing that because I applied too much force. It's jumping up to 4, but with the mass, it should slow it down some because it's not enough Newtonian force. All right, so what you need, right? Let's get to that. Is a snapshot of what you're working on, and you're gonna put that into, like we did. Well, I think I did this in a different class. You're gonna click on screenshot, and once you click on screenshot, it'll download a snapshot of what you're working on. So you're gonna take that and insert it into your Google Doc. So let's put that here, and all I gotta do is move over 1 space down, go to insert, image, and upload from computer. A menu should pop up which allows you to select the image, and if you went to your downloads where it should have went when you did the snapshot, you'll have this representation of what's on the screen. You click on it or select it, click on open, and there's a snapshot of what we just worked on. Now you guys need 2 snapshots, right? What I need you to do for your snapshot is, let's see here, you're going to actually use, see, can we do it this way? A present, and the present has some unknown mass, but you got to use different combinations like I have. So you also have heavier objects over here, if you didn't notice. Your combinations, this is the first snapshot you got to make, right? So you have this trash can, which is about 100 kilograms. You have this guy, it's 80 kilograms. You need that. You need to have a speed of at least 3. So you got to change your newtons, right? Take a snapshot once you get that going. Don't forget to have all of these values selected. Next, let's recycle everything. You need to take a refrigerator. So we're going to put the box back because the box is heavier. Turn on all your values too, by the way. There we go. And you're going to use a refrigerator. And on this attempt, you're going to be going against using this guy here, the wooden character, against. You're going to be going the opposite direction. So with that said, you need the refrigerator and you need this person sitting on top of the refrigerator. All right?
Excuse me, Mr. Tyler.
Yes.
My newtons won't stay.
Well, you got to click on the arrow, Lisa.
Oh,
So to see this arrow here, if you click on it once, it'll give you something. Now, if you click on this arrow, it's going to give you too much. It's kind of like fast forward and forward. So in this situation, you're going to apply some newtons, and you'll notice it's a negative newtons amount because it's going against the direction that we were supposed to be going. So it's going in a negative direction. You got to click on it a few times if something happens. Don't get frustrated. But if you notice in the middle of the refrigerator, there's an arrow that's growing. So to help you out, like you can click on this button and it'll give you a jump of however many newtons. So for this one, it's negative 62. All right. So you need at least enough to get it to 3. And I think that's more than enough because I'm at 112 negative. You need to get this going and have it look like I have. But don't forget to go to your screenshot, download it, and then come back to your Google Doc again and come down one and put your image. That's the link. That's not what I wanted. I got to insert it. I don't know what I was thinking about. All right, so you're going to click on insert because this is the new document, right? And I downloaded it here. When I hit screenshot, if you're not familiar where screenshot is, it's always right here in this corner. There's 3 dots. And go to screenshot. It'll download the PNG file. You go to your document. You click on insert, image, and upload, just like we did for the previous screenshot. Find that new screenshot and hit open. Okay, so you have 2 images in your document. Now it's time for us to begin the problem. So I'm going to come down here and I'll begin what you need for notes in the problem. Okay, so you should have this much. If you don't panic. You got till 8 to go back and get that simulation done. But what if I would do if I were you is I would save the link for this application or this simulation in your document so you can always come back to it. And if I see that, I will give you extra credit because that means you were listening. So this is the simulation you're using. And these are the 2 simulations you made in terms of what Lisa already described, position and motion. Okay. So what do you need to do this equation? Well, to do this problem, you need an equation called position, time, and it's equation of motion. Okay. And we'll center that because that's part of your notes, and then I'm going to type the rest of the notes up for you. I'll even put this in the chat in case it's hard for you to see, but bear in mind there are some letters that are subscript, so they look mathematical. So what does that look like? We talked about XF. XF is equal to XI. Okay, Courtney, you beating that laptop up, brother. I'm gonna mute you.
Oh,
Man, hear him
I
punching
didn't
that
know
laptop.
my mic was on.
It's okay. Just mute yourself, dude. While you fight with your laptop. Okay, thank you. He's over there, Mike Tyson punching out the laptop. All right, so XI plus. I'm on the wrong screen. Come here. plus, what do we say? dt, right? So that's velocity multiplied by time. Right? That's a lowercase v. All right. So this is what you need so far. Lowercase x, lowercase x. Then what happens is there's subscript portion. So this I is subscript. Now I'll change the font so you can see it better. But you got to set it up the same way I'm setting it up, or it won't make sense mathematically. So that's xi. And this would be your xf, and they're both subscript. Let's give that a little bit of font size. So let's go for, I don't know, 12. Still not big enough, probably. How about 14? And then I'm going to zoom in some more to help you out. So this is what you should have, right? I want you to see that. Now, what does each of those mean? Well, as far as in dimensions, your xf is going to be measured in meters. This is going to be equal to your xi, which is also measured in meters. Plus your v, or velocity, that's measured in meters per second. And we saw that in our simulation. Multiplied by time, which is measured in, I'd say time, in seconds. So let's write this out so you'll have it all. What does each of these terms mean in terms of words, right? So let's spell it out. XF means final position, is equivalent to XI, which is initial position, plus your V, which is velocity. That's the speed we saw earlier from the simulation, multiplied by time, t. Okay. All right, looking great. Now we can jump into the problems. We have to set up our known and unknown values. How are we doing on time? 10:42. Let's see here, we got 11:10. So we're doing good, but let's take care of the problem. Then we can open the floor up to questions. And if we get done with this, we might leave 10 minutes early. Got a few announcements. Ms. Brown found one of them, and that was about Facebook and stuff and how you can earn or win $100. But I'll come back to that before we're through. So first question, right? This is, I think, the question Lisa read already. We want to be able to determine how fast this bowling ball is moving. There's a constant velocity and starts from an initial position of 1.6 meters to a final position of 7.8 meters. And I just want to highlight that for a second because that's your first known value. And actually, it's 3 known values there. So what it asks is hey, what is your xi? Basically, it tells you it's 1.6. It says starting value. That's initial position. So we got to start with what we usually do to tackle these problems, set up our knowns and our unknown. So what do we know? I already told you earlier, we have xi because it says it has a starting value of. So I'm going to copy this from here and put my xi here. And that's going to be equal to, what did we say it was earlier? Scroll up. That was 1.6 meters. Okay. What do we have next? Well, if you paid attention, it said it ends or it comes to a different position. So let's go up and look at that. That's going to be, it has to a final position. That's XF, right? 7.8 meters. So XF, let's just take that because it's already set up for us, is equal to, bring that over. And that's equal to, it is 7.8 meters. Okay. Going up, going up. Yep, 7.8. They also give you a time of 3.1 seconds here. So we're going to say time, which is t, this part of the equation, is equal to it over. Is equal to, what did it say, 3-some seconds? Okay, Courtney's left. Hope he's coming back. 3.1 seconds. All right. Now we got two parts to this problem, I think, part A and a part B portion. We go up here and take a look at what they're asking us in part A. So in part A, they're saying, hey, what is the position time equation for the bowling ball? So that's easy because we're just going to use what I gave you, which is the position time equation here, right? So that's part A. Put in our unknowns. I don't think I'll be able to turn this one in. LOL. Lisa Trip. So part A is asking for position time equation. Right? And then that's going to be in the form of basically this here, but with the values plugged in. And we have most of the values. We just don't know what the velocity is, right? So in order to do part A, we also need to know what? Well, one, we need to know what velocity is. That's going to be in meters per second. You got to do some algebra there. Also in part A, we need to know this equation as it's filled out. Okay, so we'll figure out V because it's needed for part B. So let me come down here. In part B, you're going to need what? Well, if you look at part B, it says, let's go up. At what time is the ball at position 8.6? Now, if you remember in the problem, it says you have a constant velocity, but they didn't give you the velocity. So that's where algebra is going to come in and help you out there. And we're going to use this equation to figure it out because we have everything else but the velocity. So this one is asking time, and that's going to be equal to some number in seconds. Now, this is a new time. It's not the time you got over there. You're going to use this time to figure out what velocity is. You're going to go back and figure out what time using other values. Again, what's your new velocity? Okay, so we got all those parts. Let's jump into the problem. So part A is going to require us to do algebra. I remember mentioning that to you guys earlier, and that's what the problem is that we're working on. So XF is equal to XI plus the velocity multiplied by the time. Now, before we even get started, let's do what part A is asking. What does the equation look like? And to figure that out, you just put the equation in with the values you have. So knowing that XF is 1.6 meters, right? And that's going to be equal to, I'm just following the equation, XI is 1.6. I'm sorry, ooh, I messed up, 7.8. There we go, moving too fast. 7.8 meters is your final. Your initial position is 1.6 meters plus, what else we got? The velocity we don't know, multiplied by the time of 3.1 seconds. Okay, so that's pretty much the answer to part A. Just putting it into the equation without the velocity known yet. So in order to move forward, you still got to figure out what velocity is. So I'm going to copy this and come down, and I'm going to solve. But I'm going to highlight this one because that's the answer to part A. That was all you had to do with part A. Okay, I'm going to bold it. Make sure you have that one. Okay. The next step is now use algebra to solve for velocity, which is V. Okay, so how do I do that? Well, we know what we have to do with algebra. We want to get everything around the velocity onto the other side of the equation. So let's go through it. Well, the first thing I want to get rid of is that 1.6 meters that's next to the velocity. So in order to do that, I have to say minus 1.6 because that 1.6 is positive. I'll put this in red because that's a change to the equation. In algebra, don't forget what you do to one side, you always have to do to the other. So you got to stay consistent. We're going to take this value that we changed the equation by, and copy it, and I'll come over here and put it there. So those are the changes. Take this line and come down one, and some things cross out, right? So what crosses out? Well, if we're looking, this 1.6 is positive, and this 1.6 is negative. Okay, Angelique disappeared. They got to come back, and this is what their attendance. All right, and so I'm gonna strike these out that are no longer there in the equation. Okay, so this one's gone, and this part right here is gone too, because that makes 0, and now you just have velocity multiplied by the 3.1 seconds. So strike that out. And now you have a new situation here as well that has to be combined. So what is 1.6 and 7.8? Remember, 1.6 is negative. That's a quick Google calculation. So that's going to be basically, you can write negative or equal sign first, right? 1.6 minus 7.8. You enter and it gives you a negative 6.2. So this here becomes a negative 6.2. And let's move that over. And let's not forget that this part is gone. Let me bring it down, right? And this part is gone. Okay. I think something went wrong there because my striked out parts went away. Let me go back. Yeah, okay, so that was a strikeout part. I should have brought it down first. Let me do that. But something don't look right there. There we go. So this is gone. And this part is gone. But we said this will become, I think it was the 6.2. And it's not negative. Okay. There we go. That looks a lot better. All right. Let me just clean this up for you guys. Awesome. Okay, so I hope you're following along. These are the steps we did algebraically to get velocity by itself. But we're still not finished because velocity is not by itself yet. We got to still combine, still get rid of this multiplied situation of velocity in 3.1 seconds. Now, the reverse of multiplication is, of course, division. So we're going to take this step and go down one. And all of this here, let's put parentheses around it, will be divided by what we don't want, which is the 3.1 seconds. We're doing the opposite of multiplication there, right? Let's do that. If you do one side, you got to do to the other, right? So this is the change that we made to the next part of the calculation. And then, like I said, what we do to one side, we do to the other. So let's take this over there on the other side of the equation. And we're going to put this in parentheses, so all of it's included. And it's going to be divided. Okay. So now what? Let's take this equation and see what shrinks. Okay, well, we know that the seconds here and the seconds on the bottom of this will cancel out, leaving just 1 times velocity, which is just velocity. So 3.1 seconds divided by 3.1 seconds, they cancel. This is gone as well. And these two combine by just dividing them, and we'll only have seconds. Now, seconds is going to be raised to the -1 because it's in the bottom, which is really okay because you could just raise it to the negative power. It means it's a very small amount of seconds. So that's why this is not negative. Remember, this is positive. It was 6.2 positive. What I'm saying is seconds is going to be on the bottom. So we got to get that off of there. There we go. There we go. So what does that become? That's 6.2. 6.2.
I gotta refresh.
You gotta do what, dear?
Thing is making your voice lag.
You can hear my voice? Oh, she said you gotta come back. Okay. All right, so basically 6.2 divided by 3.1 is going to be 2. So we come here, and we're going to say this is basically 2 seconds, right? And now all we have is, and it's actually, this is the part that was confusing people. It's meters, but 6.2. So it's not confusing to you guys. Here we go. All right. So that looks awesome because now it's in velocity per second. I was looking at that like, why is it not meters per second? Something's wrong. There we go. So we end up with 2 meters per second. And this is going to be equal to velocity. Welcome back, Lisa.
Thank you.
Velocity is always measured in meters per second. That's part A in essence. But now we have to get ready. Let's see here. It's 10:56. And we get out of here at 11:10. So let's push on to talk about how to do part B, right? Because we're not done. That's in seconds. And I want you guys to have that because basically your 2S problem is almost identical. All you got to do is just use the same steps and recalculate. So we need the velocity. We got it. That's 2 meters per second. I'm going to underline that and bold it because we got to come back to that and use it. Now in part B, they're saying, hey, where's part B at? At what time is the ball at position 8.6 meters? So in part B, there's another known value that we got to add to our setup. So part B, and this known value is basically says time position at 8.6, right? So that's XF. When it finally gets to that, it's going to take the XF from here. And say, hey, what is it going to be in part B when you do it? Well, when it gets to a final position of 8.6 meters, and we're going to figure that out real quick, right? So let's go through it. 7.8, 1.6. And we'll come here and continue working on that part of the problem. So looking at it, we got to use our original equation, which is our position time equation for motion. So coming here, this is the same equation, but now we got to use it to find, because we now found a constant velocity, we have to use it to find our actual new time. So it's a little more algebra, and then we're going to finish this up. So now use the constant. Should be typing as I'm typing, everybody. Velocity found above to calculate the new time. Okay. I should say via algebra. That's what we're about to do, basically. We're going to solve for algebra now. Let me solve for time now. And time is in t. So what does that look like? Let's run through it real quick. We're going to do some of the similar steps to get rid of everything around time, but now we're doing it for velocity. So I'm going to take this here, this equation, which is the equation we used before.
Ah!
Hey, what's going on? Somebody screaming.
Oh, my bad.
Okay, okay. So let's go ahead and solve for time now without putting the values in yet, because these things will get messy. So basically, I'm gonna put it again. And how do we get rid of time? Get rid of everything around time? Well, first is the xi. So we can say subtract xi on both sides because it's a positive xi there. Then don't forget what you do to one side, you got to do to the other. So I'm marking in red the changes to the equation again. And then the same is true here where we have, see, we got to put plus, but I got to turn this off. Oh, okay. Hello, Mr. Irvin. Did you have the GGI link for them?
Yes, I do. I'm gonna drop
Awesome.
it in the chat. If that's
Thank,
okay.
thank you, sir. So everybody take note of that GGI link so you can get there. Mr. Rush is kindly providing it for you. Okay, so these are the changes to the
That's Mr.
equation.
Irvin.
It's okay, Lisa. We know what Miss Tyler meant.
Sorry, Mr. Irvin. Trying to go too fast. It's almost out of time. And thanks, Lisa. So let's continue on. We have to strike out some things, right? Because we have a new equation in our system. So xi is gone. Y'all might get out of here 5 minutes at most, but I want to finish this off so you at least have it for part B in the next problem. So strike this out. And then strike all this out too. Okay, now we got a whole new equation and we can rewrite it as such. So what does that look like? Well, come down here and basically this part is gone. And this part is gone too. Now we're ready to put some values in, but before we do, we got to get rid of time rid of velocity that's next to the time. Here. And in order to do that, we're going to divide by the velocity on both sides. Just like we did earlier. We'll divide by v. Then what you do to one side, this is the change. You got to do to the other. These are basically two-step algebra problems. This will divide into both of these values here, but they'll combine to get smaller, so don't panic. Turn that off and put that in parentheses. And it's divided by that same velocity. Okay, let's cancel some things out and make this look better. And what it cancels, again, this is gone. And that velocity is gone too because they cancel each other out. And what do we got? We had a new equation over here where velocity divides into both. But this is the part where we rewrite the equation and just basically you will put the values in and finish the problem off. So let me rewrite it for you real quick. Basically, all of this is just going to be time. And it's v equals that. So put the values in. It's 1104. You can put the values in. I'm gonna put a few in, and it should get easier for you because we have a new velocity, which is this 2 meters per second we found, and we have xf from earlier and xi. But one last thing before I get ready to let you guys go, I do want to. I didn't have time to mention the Facebook. You should join our Facebook page. You get $100. You can see the information inside of SB. Follow up with the staff member's name on there. So what is this equal to? Okay, we just simplified it. Let's put all the numbers in. It's going to be up to you to finish it off. Let's not forget. So I'm going to put the values in. That's what, 2 meters per second here. And what goes here? Well, those values are above, and you combine them. So it's 1104. And when I say above, you're using these same values here. So that's 1.6. So I want to make sure there's no room for error. The negative 1.6 meters plus, I think it was 7.8. meters. And it's up to you to finish that calculation off. Don't forget you have an asynchronous problem that is identical only in terms, but far as numbers, put that asynchronous problem in the chat so you don't forget to take that with you. And make sure you get the link from Mr. Irvin in the chat as well. But that's your second problem. It should go in your Google Doc along with the rest of this. You're not done with this because you got to calculate the final answer. This is in terms of time, not V. That's why I knew something was off. There we go. And this is the second problem. Okay. So I think that's everything. You have any questions? 11:05. I think GGI starts at 11:15. You have any questions for me?
No.
Okay. Well, I'll see you later. Use this time to, stretch and get ready for GGI. Take that link for Irvin so you can get into the room in time. You all are free to go. Jacqueline, are you there? Okay. Lisa left. Angel, are you there? You're free to go, but you got to turn everything in by 8 p.m. So check out the video. It'll be ready soon.
8 p.m. today?
Yeah, 8 p.m. today. That's the homework problem and the in-class problem we just did. Also, did you get the link from Mr. Irvin's GGI?
Let me see.
It's in the chat.
Yeah, I see it.
All right, make sure you copy that to some browser tab and be ready to go to GGI at 11:15.
All right.
All right, see you later.
All right.